Hello everyone. So in this video, let us talk about the first three problems from the latest Leetcode weekly contest 284. So let's start. The first problem is find all k distinct integers in an array. So I'll read the problem statement. You are given a zero indexed integer array nums, that is as you can see here. Yeah, and you're also given two integers key and k. Now a k distinct index is any index I of the nums for which there exists at least one index j that is at least k distance away, like at max k distance away, sorry, and has nums of j equal to key. Now in simple terms it says that you just have to tell how many k distant indexes are there in this nums. Now if we just tell you in simple terms, k distant index is any index I such that for that index you can find out one more index j that is at most k distance away from that I, and that value is equal to key. So nums of j equal to key. So I'll take you the first example so that it will become more clear to you. Let us write down the first example. So it is 3491. So 3491 3491 395. Okay, now the key is equal to 9 and k is equal to 1. Fine. Now what the problem statement states that let us check one by one for every number. For this index, can you find out at a distance of 1 from the left or right, because it is mod. So if you just go one distance on the left and one distance on the right, this is outer bound. Can you find out a value of 9 here? So the value of 9 is here and here. Okay. Now, so this index is not correct. For this index, 1 on the left and 1 on the right. Can you find out a value of 9? Yes. So this is a k distant index. Similarly for this, I can in this region from this to this, because k, which means that the distance of I minus j, the index of which you want to find out, and the index you currently on, the absolute difference should be less than or equal to k, which means that on the left and right side both you can take. Okay, and if you can find out any value that is equal to like the key, then the answer is that this index is a k distant index, and you just have to print out all the k distant. So as you can see that 1 and 2 are there, and you can just prove that all the 1 to 6, all of them are printed. So because the constraints are very small, you can just do a brute force way. What I can do in a brute force way, for every index, just move from I minus k till I plus k for every I. Just check that whether there exists a number that is equal to key. If there exists, then you just put the current index I as a k distant index and just print out all the answers, and that's it. So as you can see that this is the answer vector for showing out all the final answers. Just iterate for every index I from 0 till n. For every index, just move your j like the second, because it is O of n square. So the j index from I minus k to I plus k. You just have to check that. You also have to check that because I minus k, I plus k can go out of bound. So this j should be inbound. And if the nums of j is equal to key, then you just push out the current index I in this answer vector and just like print out the final answers, whatever answer is there. And that's the overall problem and the solution for the first problem. Let us move on to the second problem. The second problem is count artifacts that can be extracted out. Now this problem is also simple. You just have to understand the constraints very easily. I'll tell you all the things. So the problem statement states that you are given an n cross n zero index grid. Now there are some artifacts. Now artifacts are zero index 2D integer array. Okay, and artifacts are described by rectangular artifacts. So these are rectangle. Now to describe or like to illustrate a rectangle in a 2D grid, you just require two coordinates actually. Okay, so R1 C1 and R2 C2. So this is one coordinate, this is second coordinate. I'll tell you in simple terms what I mean. So let's say that you have some grid. Okay, now you want to describe a rectangle here like this. Okay, how can you describe a rectangle here? So if you have the top left point and the bottom right point, you can just form a rectangle. So to form any rectangle or to describe any rectangle, if you have a top left and a bottom right point of any of a rectangle, you can describe what rectangle you're talking about. So in this also problem, there are different artifacts, and the top left, as you can see, the bottom right points coordinates that is given to you. Now, so this is some, you can see that this is some sort of an area like a land. Now, and these are artifacts that are inserted deep buried inside that land. Now this is one artifact. So as you can see that in the example 0, 0 till 0, 0. So only the first grid point is there. In the second one 0, 0, 1 from this point to 1, 1. So this is the complete, as you can see that the complete rectangle is the complete artifact. Now you started digging out some lands out so that you can extract out some artifacts. So you are also given that you dig out these cells. So you dig out 0, 0, that is this, and 0, 1, so this. Now after digging out these lands, you have to just tell that how many artifacts you have completely extracted out. Now you can see that in the example that the first artifact is completely extracted out because it only consists of one block. The second artifact consists of these two blocks, and you only extract out the first block, like you dug out, as you can see in the dug vector. So it means that this artifact is not completely extracted out, and thus you can only find out one artifact. But then the second example, the same like grid is given to you, but now you have dug 0, 0, 0, 1 and 1, 1. So this artifact as well as this artifact is like extracted out, and the answer is 2. So that's the whole problem. Now coming on to the constraints, as you can see that n is 1000, that the grid size, n cross n grid size. So it is 10 to the power like n square. You can see it 10 to the power 6. Similarly, the number of artifacts is such that it is the minimum of n square and 10 to the power 5. Now when I see this constraint, I understand that n square can 10 to the power, like n square, the maximum is 1000. So 1000 10 to the power square is 10 to the power 6 and 10 to the power 5. So minimum of 10 to the power 5. So it is some sort of like you have to use some sort of O of n or of n log n approach to solve this problem. And thus I start to like thinking of some prefix sum, because for every artifact I have to tell in O of 1 or O of log n that whether I can extract it out like using given this dug array. Okay, but I thought that this might be very confusing and it might become very tedious. But then I come down to this line, and this is also highlighted. So it means that the total number of cells covered by any artifact is at most 4, which actually means that the artifacts is very small, and thus even if there are like very large number of artifacts, the number of like the size of the artifact, the rectangle that the artifact will form is very small, and thus you can just do a very brute force way checking for every artifact because the artifact is very small. So what you can directly do is that you can first make a grid of the blocks you have extracted out. So you can like first make a grid of n square n and then mark out all the blocks that you have dig out, so that you have a grid in which all the blocks that you have dig out are marked. Then for every artifact you can just check out that whether it is possible to dig out that artifact, because the artifact size is very small. So it is some sort of an O of 1 approach only, because for every artifact you just required to check at most 4 blocks. So it is like O of 1 approach only to check that whether any particular artifact is extracted out or not from that ground, and that's the whole solution. So nothing more complicated. So as you can see that you just make a boolean array like area sort of a land, and then mark out all the land that you have dug out by true. Then check for every artifact. I just mark it as true that I can found out. For every artifact, just do a for loop. So for every row, because I have told you that top left and bottom right, from row is from this particular index to this index. So as you can see that the first point is the row and the second like this. So 0 and second. So these are the row. So I have just iterated over a for loop from this point to this point. Okay. And similarly for column. And if at any point I just find it false, which means that that particular like area that I'm looking for that particular artifact to be extracted out, all the blocks under that artifact should be true. If any of the artifact block is false, which means that I have not extracted out completely, and thus you just mark it break and just not mark it, like that artifact is not particularly extracted out. Okay, else if you can extract out all the particular blocks, like all the particular blocks for that particular artifact extracted out, you just mark it as true and just print out the answer. And that's the whole solution for second problem. Nothing more complicated, just brute force way. The third problem is maximize the topmost element after key moves. So it is also a good problem, nothing more complicated. You are given that a 0 index integer nums array that you are given, and the 0th, like the nums of 0 is the topmost element. So you're just assuming that this is a pile. Okay, so this is some sort of a pile, and the pile is some like stack, you can just assume, and the pile is in this format. So I just draw it out. So the first for the first example, 5 2 2. So 5 2 2 and then 4 0 6. So you can assume that it is like this. Okay, now in one move you can perform either of the following like steps. If the pile is not empty, remove the topmost element of the pile. So you can you can do two steps. Either you can pop out the topmost element, that is fine, or else if there are one or more removed elements, so now you are popping out elements, so you have some removed elements. If there are one or more removed elements, add any one of them back onto the pile. So you can add back onto the pile again, okay? And then that element will become the new top. Now you are also given some k, so you have the total of k moves you can do. Now return the maximum value of the topmost element after exactly k moves. Fine. So you have to do exactly k moves such that after those k moves, what is the maximum top value you can get, and that's the whole problem. Now you can read the problem state like the examples that will actually help you to get more more clarity. But I just focus on this example first, so that as you can see that nums is equal to 1, so there is only one element, and k equal to 1. Now if I have only one element in the stack, that is 2, and I have a k that I can do only one move, so because I have only one move and I can either pop out element or put some element. Because I have nothing to put, I can only have one option to pop it out. So if I just pop out, there is no more element left in the stack. So the answer is that there is no more element, so answer is -1 because the topmost element is nothing. Okay. Now if let's say that I have k equal to 2. So in the first chance I can like pop it out, and second chance I can like put it out. Put it back. So and similarly if k equal to 3, I have to like pop it out, put it back, and then pop it out. So it means that for n equal to 1 and k, if k is even, so n equal to 1 and k is even, then the answer is like the topmost element, that is nums of 0. Else if k is equal to odd, then the answer is like -1 because I cannot do anything. Okay, so this is how the general approach is. For let us say that for all the other cases when n is greater than equal to 1, then what will happen? Let us take some example. Let us take that I have the numbers like this: 2, 3, 5 and 6. So let us draw it like this: 2, 5, 6. 2, 3, 5, 6. Okay. Now let's start taking out the k. For k equal to, let's say 1, I have only one choice to like pop out this element. Okay. Now for k equal to 2, okay, for k equal to 2, what it actually means is I can pop out the first element, okay, and then this element will be on the top, okay, and then I have k equal to 1 more left. So either I can like put this element back, okay, I can like put this element back, or I can pop out this element also. So there are two options. Either I can pop out this 2 as well as pop out this 3. So 5 will be on the top. Okay, or I can pop out 2 and put 2 back. So if I pop out 2 and put 2 back, it will be like this again. So the maximum is this. But what I'm trying to say here is that let us not think in this direction, but let us think in the direction that whatever numbers I have, can I somehow make this number on the top? My problem comes down to this: can I somehow make this number on the top? Because what I can do is that I do not know what is the maximum number, but what I can do is that if I somehow make this number on the top, I can say that like let's say that can I make this on the top? Can I make this on the top? Can I somehow bring this on the top? If I know that I can bring anyone on the top, I just find out the maximum of them, and thus I have different options. So among all the different options I can get, which I can bring on the top, I just make out and find out what is the maximum of them. I hope you get the point. So among all the options I can get, okay, after doing this k of operations, what all candidates I can bring on the top, among all those candidates I will just find out the maximum one, and that's the answer. But how can I check which candidate will I can bring on the top? That's what I'm going to check. So what you can say that if k is equal to, let's say 2, so it actually just means that I can pop out the first 2 elements and I can get this element on the top. So that is one of the answers, that whatever k is there, okay, I can bring that particular index. So this is 0, 1 and 2. So I can bring the second element on the top because I can pop all the elements. That is one of the options. The second option is that, okay, can you tell me how much k I have such that I want to bring this element on top? Okay, so what you can see that if I have k equal to 1, I can just pop out 2. Okay, I cannot. But if I have k equal to 2, I can bring 2 back. As you can assume that if I want to somehow bring 2 on the top, if that is my opportunity, if I want to do that, what I can do is that if k is equal to 2, I can first pop it out and then bring it back. If k equal to 3, can I somehow make like 2 on the top? Can I somehow bring 2 on the top? Yes. How? I can first pop out 2. Okay, then I have the element that is left equal to 5, like 3, 5, 6. Then I will pop out 3 as well. So I have only element 5 and 6. And then among all the elements that I have, that is 2 and 3, I will push 2 back on the top, that is this element. And thus I will have 2 on the top. And thus what you can observe is that for the first element at I equal to this, I have to first pop out the elements till this element. So what you can observe is that for the first element, I require greater than equal to 2 steps, because for 2 steps also, for k equal to 1, I cannot bring the first element on the top. Why? Because in the first k equal to 1, if I have just k equal to 1 and I just want to bring the first element on the top, I cannot do this, because in the only k equal to 1, I just can pop it out. For k equal to 2, I can do that. For k equal to 3, I can do that, and so on. So for any k greater than equal to 2, I can bring out and bring the first element on the top. Okay, so k greater than equal to 2. For this element, can you tell me that? For this element to bring on the top, for k equal to 1 I can do? No. For k equal to 2 I can do. Can you tell me that? For k equal to 2, I can first pop out this element and then I can bring out this element on the top. That is fine. Okay. Like for k equal to 2, for k equal to 1, I can bring out this element on top because this is on the first index. For k equal to 2, I have 2 steps. So for k equal to 1, I can bring on the top because this is on the first index only. So k equal to this. K equal to 2, can I do that? K equal to 2, I can just pop out this element. And if I just pop out this element as well, this element is not on the top. For k equal to 3, I can pop out the first element, second element and bring this back. So it means that for k greater than equal to 3, I can do this. And similarly, you can check that for this element, k greater than equal to 4, I can do this. And thus this is just so k is if the particular element I am on, so ith element. Okay, so if ith element is greater than equal to, so if let's say that I have, or let's not do this. If k is greater than equal to I plus 2, what I'm trying to say is that for index I equal to 0, this is like 2. Then for I equal to 1 plus 2, this is equal to 3. So what I'm trying to say is that you just have to somehow map out this number to these numbers. So if you are trying to understand that, what I'm trying to do here is that for every number, for the first number to bring on the top, I require greater than equal to 2 steps. For this number to bring on the top, I require greater than equal to 3 steps. For this number on the top, you just require k equal to 4 steps and so on. So if I have k greater than equal to 4, I can bring this number on top, but I cannot bring this number on top. And thus, whatever k you have, according to that, I just find out the maximum I can get by the given k and just print out the answer. And that's the whole problem. I show you the code. So the first case is that if n is equal to 1 and k is even, then print out the first top element or else the minus 1. Else you just have to find the maximum. So you just do a for loop from left to right. Either k is equal to I. Okay, the ith element you're looking for is equal to k. For that element, you can take as a possible candidate, you just maximize it. Or for any I, if I plus 2, if k is greater than I plus 2, then for that particular element, you can also take out to be the particular candidate. Okay, so this is just that for, let's say that for the first element, you require to be a candidate such that if k is greater than equal to 2, I can take the first element to be a candidate. So for I equal to 0, this becomes 2, so k greater than equal to 2. Okay, for second element, I just want for second element to be a possible candidate, my k should be greater than equal to 3. So if k is greater than equal to 3, then the second element can also be a possible candidate. And that's the whole solution. If, as you can see that if k is equal to 3, the second candidate will become a possible candidate, the third candidate will also become a possible candidate, and so on. And you just print out the maximum among all the possible candidates, and that's the answer. So that's the whole solution for the first 3 problems from the latest Leetcode solution. If you have any comments, if you have any doubts, you can do mention it in the comment box. Thank you for watching this video till the end. I will see you next one. Till then, keep coding and bye.